Hi everyone, Mr. Colella here. I want to give you a quick recap of exponent rules for you to use this week. Here you go. First, we have the product of powers rule. So that's when you're multiplying bases that are the same. You're going to add the exponents and keep the base. So something like 3 to the 4th times 3 to the 5th. That's just going to equal 3 to the 9th. We keep the 3 as the base, and then we add 4 and 5 together. We can do that with variable bases as well. So, say we have x to the 7th times x to the 5th. 7 plus 5 is 12, so that's just going to be x to the 12th. So when we have same base, different exponent, we're going to keep that base, add the exponents. Let's move on to the next one. We got power of products rule. That states that when multiplying different bases with the same exponent, you're actually going to multiply the bases and keep the exponent the same. So as a quick example, we could have something like, let's say 2 to the 3rd, and let's say we're multiplying it times 12 to the 3rd. Same exponent, so that'll stay in our answer. We're going to just multiply 2 times 12 to get 24. So that'll just be 24 to the 3rd. Okay, just give you another quick example here. Let's say we're saying 5 to the 5th, and that's being multiplied by 4 to the 5th. That would simply just be 20 to the 5th. All right, let's move on. We've got the power of powers rule. So that's when we're taking one exponent and raising it to another. If that's the case, we simply keep the base and we multiply the exponent. So that would be something like this. Let's say we have 3 squared, but let's say that's being raised to the 4th power. 2 times 4 is 8, so that's just going to be 3 to the 8th. You can do that with an exponent as well. Let's say, I don't know, x to the 5th, and let's square that. 5 times 2 is 10, so therefore we have x to the 10th. So just take your two exponents, multiply them together, keep the base. Alright, we're going to keep going here. We've got the quotient of powers rule. Now the quotient of powers rule states that when you have two bases that are the same, you're just going to subtract the exponents and you're going to keep the same base. So that would be something like 4 to the 8th divided by 4 to the 3rd. You'll keep that 4, and then 8 minus 3 is 5, so 4 to the 5th. Again, let's do that with a variable. Let's do x. We'll say x to the 7th. Let's divide it by x to the 2nd. 7 minus 2 is 5. So that's, of course, x to the 5th. Just be careful here. If you have any negatives, remember your rules for adding and subtracting integers. So let's say we had something, I'll do this one in a different color so it stands out. Let's say we have x to the 5th, and we are dividing it by, let's say, x to the negative 3rd. Now, here we'd have to do 5 minus negative 3. 5 minus negative 3 is actually 8, so this is actually x to the 8th. So just be careful when trying to add or subtract with negative numbers. Okay, we're going to go to the next rule. It's the negative exponent rule. So whenever we have a negative exponent, it's going to be equal to a fraction with a 1 as a numerator, and then the exponent just flips to a positive. So say we have something like 4 to the negative 3rd. We're just going to make a fraction. 1 is that numerator, and 4 to the positive 3rd on the bottom. Do that with a variable. Let's use a y this time. So let's say y to the negative 5th. That's just going to be 1 over y to the 5th. So same thing, you're just changing it to a positive and you're putting a 1 on top. Alright. Last but not least, we have the zero power rule. It's probably the easiest of all of them. That states that any base raised to the 0 power is equal to 1. I do not care what it is. We can have anything here. So we can say 5 to the 0. We could have 99 to the 0. We could have x to the 0. It does not matter. If it is raised to the 0 power, it is equal to 1 every single time. Those are your exponent rules. Hope this helps as a quick review to get you going. Have a great week.